Hello and welcome, learners and viewers. I'm excited to have you here as we embark on a challenging learning journey. In this lesson, we will be exploring into the fascinating world of square roots. Before we proceed into the main content, let me introduce myself. My name is Janellen Hermo from BS in Math 3A. I'm your instructor for this session. I have strong passion for mathematics and teaching, and I'm here to make learning about square roots an enjoyable and rewarding experience for you. Today, we have set some specific learning outcomes. In our lesson, what we call Take a Challenge. In this lesson, challenge yourself to attain the learning outcomes. First, define and understand the concept of squaring a numbers and finding its square roots. Second, find the square roots of a perfect square through various methods using prime factorization. Third, solve problems involving finding the square roots of perfect squares. But before we get started, let's take a moment for a pre-activity. Count the number of squares. I want you to count the number of squares that we have here. Take a look at the screen and count for number 1. How many each have in number 1? Okay, great. 1. How many square in number 2? Right, 4. And in number 3? 9. Great. And last, number 4. How many squares have? 16. Great job. Now that we have our mind focused on squares, let's move on to our main topic, square roots. But before we delve into that, let's quickly review squaring a number. So, squaring a number, you know that the square of a number is that number multiplying it by itself. For example, as you can see, this is our free activity that was answered earlier. So now, we have a different method on how to determine the number of squares by using the squaring a number. So, in number 1, we have here 1 square. Now, when working with exponent, the bigger number to the left is called the base. The smaller number to the right is called the exponent. The exponent tells us how many times to expand the base out and multiply. And 1 squared, well, this means 1 times 1. The base of 1 expanded out 2 times. So we are multiplying that number by itself. And we know that 1 times 1 is equal to 1. And 1 squared is also equal to 1. And it's as simple as that. And in number 2, we have 2 squared. Multiply the number by itself. 2 times 2. That gives us 4. But before I move on to that number 3. I do want to mention why we call it squaring a number. If we take a look at a square, we can see why we call it squaring a number. For example, here we have a square with side length of 2. We can find the area of that square by doing 2 square or 2 times 2. So, 2 by 2 that give us area of 4. We can square a side length to find area of square. So, you can see the relationship between squaring a number and the area of a square. Now, let's move on to number 3. As you can see, we have 3 side length that we can square a side length. So, it's written 3 squared. Multiply by itself, 3 times 3 is equal to 9. So, the squares of 3 is 9. Last example for number 4. So, we have here 4 side length, then squared a side length. It's give us 4 squared. Multiply the number by itself, that give us 4 times 4 is equal to 16. So, the square of 4 is 16. In general, when squaring a number, you multiply the number by itself. This process can be extended to many positive integer, allowing you to find the square of any numbers. Now, let's go back to our main topic, a square root. You will learn that a square root is a number that, when multiplied by itself to form a product, is called a square root of the product. The operation of squaring and finding a square root are inverse operation. The radical symbols, square root, is used to represent square roots. Additionally, you will discover that positive real numbers have 2 square roots, one positive and one negative. Through interactive examples and practical exercises, will solidify your understanding of square roots. Let's take the number 16 as an example. 16 can be break down into 4 times 4, or 4 squared is equal to 16. Consequently, the square roots of 16 is 4, representing the positive square roots. Another, multiplying negative 4 by itself. Negative 4 times negative 4, or negative 4 squared, is equal to 16. Therefore, the negative square roots of 16 is negative 4. And now, let's move on to a perfect square. Let's start with the definition of a perfect square. A perfect square is a number whose positive square roots is a whole number. In other words, when we take the square roots of a perfect square, we get an integer as the result. The non-negative square root is represented by this symbol, and negative square root is represented by this symbol. It's important to note that not all numbers are perfect squares. For example, if we consider the number negative 36 and try to find its square root, we encounter a problem. The expression of square root negative 36 does not represent a real number, can be multiplied by itself to give a product of negative 36. In other words, no whole numbers, when squared, will result in negative 36. Here is the list of a perfect square roots from 1 to 20. Let's take a screenshot, and now we will provide an example. For example number 1, find the square root of 144. So, we can start by considering the different numbers and their squares to help us approximate the answer. Let's begin with 11. If we square 11 by multiplying it by itself, 11 times 11, we get 121. This value is close to 144, but not quite there yet. Next, let's try 12. If we squared 12 by multiplying it by itself, 12 times 12, we get 144. This means that the 144 is 12. Therefore, this means that the square root of 144 is either 12 or negative 12, because 12 times 12 is equal to 144, and negative 12 times negative 12 is equal to 144. Now, if you don't have a calculator, we have a various method to find square roots using a prime factorization. So what is prime factorization? Prime factorization is a fundamental concept in number theory that helps us break down any number into its prime components. Prime numbers are special numbers that have only two factors, 1 and the number itself. In other words, they cannot be divided evenly by any other numbers. For example, 2, 3, 5, 7, 11, 13, 17, 19, and so on are prime numbers. A composite number is any whole numbers greater than 1 that has more than two factors. In simple terms, it is a number that can be divided evenly by a number other than 1 and itself. For example, 4, 6, 8, 9, 10, and 12 are all composite numbers. So now let's have an example. To find the square root of 324, we have to reduce this number 324 to its prime factor. So let us start reducing the number 324 into prime factors. So prime factors are the factors of this number 324, which are prime. We can write 324 as 9 multiplied by 36. 9 and 36 isn't prime number. So let's reduce 9 further. And 3 multiplied by 3 is 9. So 3 is a prime factor. Next is 36. What number that multiplied 36? Okay, very good. 6 times 6. But 6 isn't a prime number. Then 6 can be written as 2 times 3 is equal to 6. The square root of 324 by factorization we get is square root of 324 is equal to 2 times 2 multiplied 3 times 3 multiplied 3 times 3. So in square root of 324, we write this square root of 2 times 2 multiplied 3 times 3 and multiplied 3 times 3. So, we have to make groups of two same numbers. This can be a first group, 2 times 2, and the second group, 3 times 3, and the third group, 3 times 3. We basically form pairs of same numbers. So we have two pairs of same numbers here, 2 times 2, 3 times 3, and 3 times 3. Once we form pairs to find the square roots, all we have to do is to pick one number from each pair and multiply them. So from the first pair, we pick 2, and the second pair we pick 3, and third is 3. And multiply 2 times 3 times 3, which give us 18. Hence, we can say that the square root of 324 is 18. Let's have another example. Find out the square root of 1764. We can break down the 1764 into two factors. We can say that 36 times 49 is 1764. And notice, 36 and 49 is not a prime numbers. That's called a composite number. We break down the 36, then we've got 6 times 6. Then 6 is also not prime number, but if we break these things down, then we've got 2 times 3 is equal to 6. So 2 and 3 is a prime number. Let's have next 49. If we break this down, then we've got 7 times 7 is equal to 49. Now, let's group these prime numbers into two pairs of same numbers. So, we have here 2 times 2 multiplied 3 times 3 multiplied 7 times 7. Once we form pairs to find the square roots, all we have to do is pick one numbers from pair and multiply them. Then we have here a 2 times 3 times 7, which give us 42. So now, therefore, square root of 1764 is 42. So, this is the end of our lesson. Thank you for joining me in this discussion on square roots. I hope you found it insightful and informative. Remember to embrace the beauty of mathematics and keep exploring its wonder. Happy learning!